We are in section 4.2 on page 7. Towards the top, it says Rolle's theorem. Assume that f of x is continuous on your closed interval from a to b and differentiable on your open interval from a to b. Then if f of a is equal to f of b, then there exists a number c between a and b such that the derivative is equal to 0. Rolle's theorem is just a special case of the mean value theorem where f of a is equal to f of b. So if you notice, the first graph that we have on here is our mean value theorem. And if you look at where f of a is equal to f of b, this is going to be our Rolle's theorem, which is exactly saying that the slope here of your secant line is equal to 0, and that is why we have up here where the derivative would be equal to 0 also. So slope would be 0. So again, a special case of the mean value theorem. The example down here says, does Rolle's theorem apply for f of x equals x to the fourth minus x squared on the interval of -2 to 2? If so, then find all numbers c that satisfy the conclusion of the Rolle's theorem. So first thing that you have to check is that our function has to be continuous on that interval. And so f of x is continuous on the interval from -2 to 2. The second thing that we have to check is that f of x is differentiable on our interval from -2 to 2. Both of these are true. We are dealing with a polynomial, which is a continuous function over all real numbers, and it's differentiable everywhere. The third thing that we have to check is that f of a is equal to f of b. So our interval goes from -2 to 2, so we have to find f of -2, and we have to find f of +2 to see if those are exactly the same value. Substituting in -2, I get 12. Substituting +2, I get 12. So therefore, we can say f of -2 is equal to f of +2. So this means that we can use Rolle's theorem, which was the first thing it wanted us to do in the problem. Second thing says, if so, then find all numbers c that satisfy the conclusion of Rolle's theorem. So Rolle's theorem, the conclusion says, taking the derivative, it's going to equal 0. So derivative f prime of x is equal to 4x cubed minus 2x equals 0. And setting that equal to 0, and factoring out GCF of 2x, we get 2x squared minus 1 equals 0. And then going ahead and setting those each equal to 0 by the zero product property, we get 2x equals 0, and 2x squared minus 1 equals 0. And then solving both of these, the first one we get an answer of 0. And the second one we're going to get x equals plus or minus, it's 1 over the square root of 2. So checking to make sure that 1 over the square root of 2 plus and minus are inside the interval from -2 to 2, which they are, then we know that these two values are going to satisfy the conclusion of Rolle's theorem. And likewise, 0 is also in the interval from -2 to 2. So that's also going to satisfy the conclusion of Rolle's theorem. So we'll say, therefore, the values of 0 plus or minus 1 over the square root of 2 satisfy the conclusion of Rolle's theorem.